In this video, we are going to focus on calculations in motion. In the last video, we explained some terms used in motion, where we explained scalar quantity as the quantity that has only magnitude but no direction. We describe vector as the one that has both magnitude and direction. We defined displacement as the distance traveled in a specified direction. Speed we defined as the rate of change of distance with time. And we explained velocity as the rate of change of displacement with time. Then we said that acceleration is the rate of change of velocity increase with time. Since the rate of change of distance with time is speed, if the rate of change of distance with time is constant throughout the journey, then the speed is said to be uniform speed. In the same case, if the rate of change of velocity with time is constant throughout, then is said to have traveled with what? Uniform acceleration. If the velocity of the body is increasing with time, then it means that it is accelerating. The body is accelerating. But if it is decreasing with time, we say that it is retarding or decelerating. With this, let's go into calculation proper. Remember that in the last video, we explained that distance is a scalar quantity, while displacement is a vector quantity. We said that distance don't have direction. It can only have the quantity as in positive. It cannot be negative. But the displacement can be either negative or positive. Let's distinguish between the two here using motion. Let's consider an object moving from point 0 from origin to about 3 kilometers. We use number line to explain this. So we have our 0 point as the origin. From this 0 point down to the left hand side is negative, while from the 0 point to the right hand side is positive. And we said that the object traveled from 0 point of origin until it covers what? 3 kilometers and stopped at the point 3. It means that the distance covered by this object is simply what? 3 kilometers. Then if the object moved from the point of negative 2 to the point of positive 2, it means that the object has covered the distance of 4 kilometers. How did we know? From here, it moved 1, 2, 3, 4, because each is a unit. So it has covered distance of what? 4 kilometers. But when it comes to displacement, the reverse becomes the case, because it's not the same way that you calculate the distance that you calculate displacement. So what are we trying to note down now? That distance is always positive no matter the direction of the movement. Now let's get the displacement traveled by the body when it moved from point 0 to the point 3. The distance, the displacement is what? The final position. Remember our formula. Final position minus the initial position. And our final position here is 3. So we have 3 minus 0, and that gave us what? 3 kilometers as the displacement. But in a situation where it moved from the -2 to the what? +2, we have that the final position is what? 2, and the initial position was what? -2. So we have the final position minus the initial position minus 2, and that will give us what? 4 kilometers. I hope it's understandable, because negative multiplied by negative is positive. Now let's consider a situation where the car moved from point 1 to the point -4. Let's look for the displacement and also calculate the distance. In terms of distance, the car traveled 2 units, 3 units, 4 units, 5 units, and each unit is a kilometer. It means that the car traveled what? The distance is what? 5 kilometers. But when it comes to displacement, remember our formula: the final position minus the initial position. And the final position is what? -4. -4 minus what? Okay, it started from +1 minus -1. And that will give us what? -5. I hope it's clear. Okay, let's look at another question. Now let's consider a situation where a car traveled from the negative point of 4 to the positive point 2, and then traveled from the point 2 to the negative point. That is, so point -1. What is the displacement? Calculate the displacement of the car. To do this, remember our formula: that displacement is the final position minus the initial position. Our final position is what? -1, and the initial position is what? -4. So we have final position minus the initial position. So, and remember that negative multiplied by negative is positive. So we have -1 plus what? 4, and that will give us what? +3. We can also find this taking another method, as that is by using the distance covered in this direction and in this direction. Then we find the difference. That will give us the displacement. The distance it's covered by traveling from the left to the right hand side is what? 1, 2, 3, 4, 5, 6. That is 6 what? 6 kilometers was the distance covered. Then let's look at the distance is covered by moving backward. That is from the right to the left direction. It was at point 2. Then he moved 1, 2, 3. But moving at this point is moving towards the negative direction. So in this case now, this will be what? Negative. So negative what? 3. So this now will give us what? We have 6 minus the 3, and that will give us what? 3. Can you see? That is the same thing. Since he traveled 6 kilometers towards the right and 3 kilometers towards the left, find the difference. That is 6 minus 3, and that gives you this 3. Now let's consider this question. A man traveled 5 kilometers due east. This is the man. He traveled 5 kilometers due east. Remember our 4 cardinal points. Here is the north, here is the east, here is the west, and here is the south. So he traveled 5 kilometers due east. And then 4 kilometers due north. That should be this. So we are asked to find the displacement. The displacement should be this distance. So let's give the displacement x. Remember that this formed a right angled triangle. In this case now, the displacement which is x should be x squared is equal to what? 5 squared plus 4 squared. 5 squared is what? 25 plus 4 squared, and that is what? 16, which will give us what? That x is equal to root what? 41. And root 41 is equal to 6.4. If a body starts with initial velocity u and accelerates uniformly along a straight line with acceleration a and covers a distance s in a time t, when its velocity reaches final value v, then the distance covered is the average velocity multiplied by time. That is average velocity multiplied by time. The average velocity is v plus u divided by 2, then multiplied by time, where v is the final velocity, u is the initial velocity, s is the distance, and t is the time. But we know that acceleration is the change of velocity over divided by time. So a, which is acceleration, is what? V minus u over t. Well, if we cross multiply, we will have that at is equal to v minus u, such that v will be equal to at plus u. In other words, we say that v is equal to u plus at, and this is what? Equation 2. While this is equation 1. As we are driving equations of the motion. In fact, let's call this equation 2. This one equation 2. So that this will be equation 3. Now, let's make t subject formula in equation 2 and substitute for t in equation 1. It then means that from equation 2, the value of t is equal to v minus u over divided by a. Okay, now we are going to substitute for this t in equation 1. That is to replace this t with this. Since t is equal to v minus u divided by a, we will replace this t with this. So since that will give us this, s will now become this. So what do we have to do? Multiply this by this. Let's write them as in form of brackets. So we have to open the brackets. V multiplied by V will give us what? V squared. V multiplied by what? U will give us what? VU. Okay. U multiplied by V will give us what? Plus what? UV. That is, UV is the same thing as what? VU. Then U multiplied by negative U will give us what? Negative U squared. 2 multiplied by A will give us 2A. So S is equal to that. So negative VU plus VU this way, because this minus this gives us 0. In that case, now we have that V squared minus U squared over 2A is equal to what? S. Okay? So, if we cross multiply, we will have that V squared minus U squared is equal to 2AS, such that V squared will be equal to U squared plus what? 2AS. And that is what? Equation 4. Remember that when this VU crosses the sign of equality, it will become plus, and that is the reason why it's like this. Remember that from equation 3, we have that V is equal to U plus AT. Now, let's substitute the value of this V in equation 1. Remember that in equation 1, we have that distance is average velocity multiplied by time. So there, that is, S is equal to V plus U over 2 multiplied by T. So here now we are going to substitute for the value of V. When we see V, this V now we will replace it with this, because this is the value of V here. So in that case now we have that S is equal to, instead of writing V, I'll write U plus AT. U plus AT. Then plus what? U multiplied by T over 2. Okay. Now let's open the bracket. Opening the bracket, we have to multiply everything here by this T. In that case, now we have that. First, let's solve the inside bracket first before opening. We have that U plus U will give us what? 2U. 2U plus AT over 2. Okay. Then let's open bracket. Then we have that this will T multiplied by 2U will give us what? 2UT plus AT squared. That is, T multiplied by this will give us AT squared, all divided by 2. This is the same thing as S equal to 2UT divided by 2 plus AT squared divided by 2. So these two cancel these two, such that we will have that UT plus AT squared. So this means that now S is equal to UT plus half AT squared. That is equation 5.